Most organizations treat the Power Platform like a harmless productivity toy. Drag some boxes, automate a few emails, call it digital transformation. Then it scales, and the same logic that felt clean at 10 runs a day becomes a pile of exceptions at 10,000. That's not success. That's unpriced complexity. The hybrid mandate is simple. Power Platform is the orchestration tier, Python is the execution tier, Azure is the governance tier. Separate coordination from computation, and wrap it all in identity, network boundaries, logging, and policy so it stays governable after the hype dies. The foundational misunderstanding. Power Platform as a tool, not a control plane. The foundational misunderstanding is that Power Platform is a tool in the same way Excel is a tool. A thing people use, a thing that sits at the edge. Something optional. That is not what you're deploying. In architectural terms, Power Platform is a control plane, a distributed decision engine that coordinates data movement, actions, approvals, identities, and connector calls across your tenant. It doesn't just automate work, it defines how work is allowed to happen and who is allowed to trigger it, and which data is allowed to cross which boundary. That distinction matters because the moment you treat a control plane like a toy, you stop designing it. And when you stop designing it, the system designs itself. It always does. When people say Power Automate is just workflows, what they're really saying is, I don't want to own the consequences of a workflow runtime that can call 1,000 external systems with the privileges of whoever clicked create connection. The platform is not fragile. Your assumptions are. Here's where decisions actually happen. Identity determines what a flow can do. Connectors determine what a flow can reach. Environments determine where it can be built and who can see it. DLP determines which connectors can be paired. Solutions and ALM determine whether the thing running in production is an artifact with intent or just a screenshot of last month's prototype. Most organizations focus on the visible part, the canvas, the steps, the triggers. That's the UI. The real architecture is the graph behind it. Entra identities, delegated permissions, connection references, environment roles, Dataverse security, and policy objects that live in admin portals nobody wants to open. So what goes wrong? Entropy. Because low-code teams, under pressure, don't build systems. They build exceptions. Just this one connector, just this one bypass. Just put the credential in a variable. Just add a condition. Each one feels small. None of them is revisited. Over time, the exceptions become the architecture. And once exceptions become the architecture, you're no longer operating a deterministic security model. You're operating a probabilistic one. The system still runs, but you can't predict its behavior under drift. When people leave, when tokens expire, when licensing changes, when a connector update breaks a payload, when throttles kick in, when a maker copies a flow to fix it quickly and accidentally creates a parallel universe. This is why it works is not the same as it is governable. A flow can work while being unreviewable. It can work while having no owner you can contact. It can work while being impossible to reproduce in another environment. It can work while quietly moving data from Dataverse to a consumer connector because somebody built it in the default environment at 2 a.m. It can work while your incident response team has no correlated logs and no idea whether the last run failed because of data, permissions, throttling, or a transient backend issue. That's the comfort trap. Success hides failure modes. Now add Python to the story. The naive question is, can Power Automate call Python? Sure, people already do it with file watchers, OneDrive polling, local scripts, random service accounts, and whatever laptop happens to be online. But the real question is, where does Python belong and what does it do to your control plane? Because Python isn't just code. It's an execution environment, packages, dependencies, runtime patching, outbound calls, secret handling, and operational ownership. If you bolt it onto Power Platform without boundaries, you don't get a hybrid architecture. You get a shadow runtime with undefined responsibility. That is how governance disappears, not with malice, but with convenience. So the right framing is this. Power Platform orchestrates. It routes, approves, schedules, notifies, and handles human touchpoints. Python executes. It transforms, validates, deduplicates, scores, and computes in a deterministic way that doesn't belong inside a flow designer. Azure governs. It provides the enforcement layer. Identity primitives, network containment, secrets, observability, policy, and lifecycle control. Treat Power Platform as a control plane, and you start asking better questions. Who is the principal? Which identity is calling which service? What is the network path? Where do secrets live? What does internal mean? Where are the logs, and can they be correlated across tiers? What is the contract between orchestration and execution? What happens when this scales by 10 times? Most people never ask those questions because the first flow works, then the second one works, then you have 50, then you have 500, then the audit shows up, and everyone suddenly discovers they've been running a distributed integration platform with no architecture. And this is the moment the low-code team hits the ceiling. Not a technical ceiling, a governance ceiling, the low-code ceiling when flows become data pipelines by accident. This is where the story always turns. The first few flows are fine. Send a Teams message, create a task, route an approval, write a row. Then the business starts trusting the automation, and trust turns into load. And load turns into ambition. Suddenly the flow isn't automation anymore. It's an accidental data pipeline. It's parsing CSVs. It's normalizing Excel tabs. It's doing lookups across multiple systems. It's joining data. It's deduplicating. It's trying to behave like an ETL tool, a rules engine, and a batch processor inside a designer that was built to coordinate steps, not compute. You can tell you've hit the ceiling by the symptoms, and they're consistent across tenants. There's the spreadsheet phase. Someone drops a file into OneDrive or SharePoint, the flow reads rows, and everything is fine until the file isn't fine. Extra columns, embedded commas, weird date formats, empty rows that aren't actually empty, a total line somebody forgot to delete. Now the flow has 10 string replacements and a set of conditions that look like a legal disclaimer. Then come the loops. Nested loops, apply to each inside, apply to each. A scope inside a scope because somebody needed a try, catch. Another scope because someone needed to continue on error. And now the flow run history is basically a crime scene. 600 actions, 3 retries, 4 parallel branches, and a final terminate with a message that tells you nothing. This might seem like a maker problem. It isn't. It's a platform economics problem. In Power Automate, every additional action is an unpriced maintenance contract. You don't pay the cost when you build it. You pay it when you debug it, version it, secure it, and explain it to someone who didn't design it. And the platform encourages this because the UI makes every step feel equally cheap. One more action, one more condition, one more compose, it's fine. It isn't. Because flows don't give you determinism. They give you last run. When something breaks, you get a screenshot of a failed action and a payload that's half context, half noise, and you're expected to reverse engineer intent from the remains. And changes don't carry versioned intent by default. A maker tweaks an expression, the flow runs, the incident stops, and nobody can tell you what changed, why it changed, or whether it created a new failure mode that just hasn't been triggered yet. The system becomes a set of invisible forks. This is also where platform limits quietly convert logic into workaround engineering. Connector throttles don't care about your business priority. Run limits don't care about your deadline. Large payload limits don't care that it's just a spreadsheet. So people start engineering around the constraints. Chunking arrays, splitting files, delaying steps, adding weights, switching to concurrency, then turning concurrency off because it causes duplicates, then adding a do not run twice flag in Dataverse that fails under race conditions. And the weird part is, all of these workarounds look like progress. They're not progress, they're symptoms of using an orchestration engine as a compute engine. So when someone asks, can Power Automate kick off Python? They're usually asking the wrong question with the right instinct. The instinct is that computation needs a real runtime. The wrong part is thinking the integration is the hard problem. The integration is easy. The boundary is the problem. Because the moment you bolt Python onto a flow without deciding where it lives, you've created an unowned execution tier. If it's a script on someone's laptop, you just made availability dependent on a human. If it's a file watcher, you just made your control plane depend on polling. If it's a service account, you just planted a credential that will outlive the person who created it. If it writes directly back to Dataverse using ad hoc tokens, you just bypassed the governance posture you thought you had. This is why the low-code ceiling is not the moment flows can't do the work. It's the moment the only way to keep doing the work is to add more actions, more exceptions, and more hidden dependencies. That is architectural erosion in real time. So the real question isn't, can it call Python? The real question is, what stays in Power Platform because it's orchestration and what leaves because it's execution? If you don't answer that, your flows will keep mutating into pipelines by accident and you'll keep paying for it in the only currency that matters in production, ambiguity. And from here, the model has to become explicit, or the entropy wins. Define the 3-tier model. So define the model explicitly before you integrate anything. Because if you don't define tiers, you don't get a hybrid architecture. You get a hybrid blame game. Power Platform is the orchestration tier. Python is the execution tier. Azure is the governance tier. And yes, these words sound like a diagram, but treat them as ownership boundaries, not shapes on a slide. Each tier exists because it is good at one thing and dangerously mediocre at the other two. Start with orchestration. Power Platform excels at coordination. Triggers, routing, approvals, human-in-the-loop steps, notifications, exception handling that a business can understand, and state tracking that lives close to the process owners. It's also where connector policy and environment scoping can actually enforce behavior at scale. The orchestration tier should do 3 jobs. Decide that work needs to happen, decide who is allowed to approve it, and decide where the results should be recorded. That's it. The orchestration tier is not where you do heavy parsing, complex validation, bulk data shaping, or probabilistic let's see what happens loops. Because once you do that, the flow stops being coordination and becomes computation, and you lose determinism, versioned intent, and debuggability. Now the execution tier. Python exists here because execution needs determinism. It needs a real runtime, real libraries, real testing, real error handling, real dependency management, and real performance characteristics. This tier is where you do transforms, normalization, deduplication, model inference, scoring, enrichment, and batch strategy. It's where you can implement idempotency as code, not as a pile of flags inside a low-code designer. It's where you can unit test the rules that decide whether a row is valid, a record should be merged, or a payload should be rejected. And the critical point, the execution tier should behave like a service, not a script, not a sidecar. A service has a contract, a service has versions, a service has clear inputs and outputs. A service can be patched without asking makers to open 50 flows and edit expressions they don't understand. A service can be monitored, a service can be throttled intentionally, and a service can be owned by a team that is accountable for its behavior in production. That's what Python is for in this model, deterministic compute that stays stable while the orchestration changes around it. Now the governance tier. Azure exists here because somebody has to enforce reality, identity, network boundaries, secrets, observability, policy, cost controls, lifecycle. The governance tier is the place where you stop trusting its internal as a security strategy and start making it true with control plane primitives. This is where Entra ID becomes non-negotiable. Non-interactive workloads should authenticate as principals, not as people. This is where key vault, managed identities, and secret rotation stop being nice to have and become basic operational hygiene. This is where network containment turns reachable into a governed property, not a convenience. And this is where logs and metrics cross tiers, so incident response becomes a query, not a group chat. A lot of teams try to skip this tier because it doesn't ship features. That's the mistake. The governance tier doesn't ship features. It prevents entropy. And entropy is what kills your features after they succeed. Now here's what changes when you adopt the 3-tier model. Not capability. Ownership. In a low-code purity world, the maker owns everything by default. The trigger, the logic, the data shaping, the credentials, the error handling, the notifications, and the downstream rights. That feels empowering right up until it becomes unreviewable. In the 3-tier model, the maker owns orchestration. Engineers own execution. Platform and security teams own governance. And the seams between them are formal. Authentication, authorization, network paths, contracts, and correlated logs. That distinction matters because it creates survivability. When someone leaves, the principle still exists. When a package needs patching, the service is updated once. When an audit asks how data moves, you can answer with boundaries, not with hope. When scale arrives, throttling and queues exist where they belong, not embedded as delay 30 seconds inside a flow. And the punchline is simple. Power Platform doesn't lose value in this model. It gains value. Because now it can stay what it actually is, a control plane for business process. While Python does what it's always done, compute. And Azure does what enterprises always forget they need until after the incident, enforce. The anti-pattern, Python as a sidecar in the shadows. The anti-pattern looks innocent because it usually starts as a demo. Someone proves Power Automate can trigger Python by dropping a file in OneDrive, then a local script notices the file and does the work. Or Python triggers a flow by calling an HTTP endpoint. It works. Everyone claps. The organization calls it innovation. What they actually built is a sidecar in the shadows. It's not an execution tier. It's a haunted extension cord. The first variant is the file watcher. Power Automate writes a file to a folder. Python polls the folder. When a file appears, it runs. The weird part is how quickly this becomes production behavior. Not because it's good, because it's easy. And once a business process depends on it, nobody wants to touch it. But a polling script is a governance failure disguised as automation. It has no contract. It has no authenticated caller. It has no explicit authorization model. It has no deterministic retry behavior. It has while true and a sleep timer, which is basically the architectural equivalent of leaving a car idling because you don't trust it to start again. Then you get the next variant, local scripts on laptops or jump boxes. The flow writes a file, a scheduled task runs Python. A team shares the script in Teams chat. Somebody pins a message with, "Don't delete this." And now the availability of your automation depends on whether a workstation reboots during Patch Tuesday. This is what incident reviews sound like. It worked yesterday. No, a person's workstation worked yesterday. The third variant is the service account, because eventually somebody gets tired of MFA prompts and broken connections. So they create automation at company.com, granted broad access, and store the password somewhere that feels private until it isn't. That account becomes the keystone of the whole arrangement. It authenticates the script, it authenticates the connectors, it authenticates the downstream rights, and nobody can tell you who's responsible for it. In architectural terms, you didn't solve authentication. You manufactured an entropy generator. And yes, the sidecar can be in the cloud and still be the same anti-pattern. A container running Python with a public endpoint, a function app with no network containment, a webhook that accepts anonymous requests because it's just internal. It has a key in a config file because we'll move it to Key Vault later. Later never arrives. Later is where security debt goes to retire comfortably. This is why Sidecar Python fails in incident reviews. Ownership and boundaries are undefined. Who owns the runtime? Who patches the dependencies when a CVE drops? Who rotates the secret? Who reviews the code? Who decides what outbound calls are allowed? Who has the logs when it fails at 3 a.m.? And the most important question, who is accountable when the script quietly exfiltrates data to somewhere that was never modeled because somebody imported a library that phones home for updates? The operational rot shows up first. The script works until a package version changes. It works until the OS updates. It works until the directory path changes. It works until the OneDrive sync client decides it's offline. It works until the maker renames a file and the parser breaks. It works until concurrency shows up and two runs collide. And when it fails in a place the Power Platform team can't see. Outside the run history, outside the connector logs, outside the environment telemetry. Your control plane loses observability exactly where you introduced complexity. Then the security rot shows up. The data path becomes outbound by accident. Dataverse data gets written to files because that was the easiest handoff. Those files land in places with consumer sync clients, retention policies you didn't design, and access you didn't review. Or the Python script calls back into Power Automate through an HTTP trigger that has no meaningful authorization beyond, the URL. That's not integration, that's a backdoor you forgot you created. And the irony is that the bidirectional arrow, the thing people love to show on slides, can be real and safe, but only if you treat it like a tier boundary with enforcement. A sidecar is what you get when you treat Python like a hack. A hybrid architecture is what you get when you treat Python like a service, and Azure like the enforcement layer, and Power Platform like the coordinator that never stops being a control plane. That's the replacement pattern. And to do it, you start with the thing everyone tries to postpone: identity. Integration paths, 2 directions, 1 governance standard. There are only 2 integration directions that matter, and both are legitimate. Power Automate to Python and Python to Power Automate. The problem is that most tenants implement both as if they're different species with different standards. One is treated as a flow calling an API, the other is treated as a script calling a webhook. Then governance evaporates because it's just automation. It's not. It's cross-tier execution, and it needs 1 governance standard no matter which direction the arrow points. Start with Power Automate to Python. This is the cleaner mental model for most organizations because it preserves what Power Platform is good at. It stays the coordinator. A trigger happens. A maker-owned process decides that computation is required. Then the flow calls a deterministic execution service and waits for a result. The flow remains the system of record for the process state, approvals, notifications, and escalation. Python does the heavy lifting and returns structured output. That output has to look like a contract, a schema, a status, a list of errors as data, and a correlation ID. Not here's a string, not check the logs. Not it worked on my machine. If the execution tier fails, the orchestration tier should be able to route that failure. Retry intentionally, raise an incident, or park the record for human review. That means the flow needs stable responses and stable failure modes. The execution tier's job is not to be clever, it's to be predictable. Now flip it, Python to Power Automate. This direction exists for a reason. Sometimes the event source isn't Power Platform, it's a data science job. It's a batch ingestion, it's an external system. It's a scheduled compute process that decides something important happened and the business process needs to run, notify a team, create an approval, update a Dataverse record through a governed path, or kick off downstream coordination. So Python calls a flow, usually through an HTTP trigger. And this is where people get sloppy, because HTTP triggers look like convenience. They're not. They are an orchestration entry point. They are literally the front door to your control plane. Treating them like a backdoor is how you end up with anonymous URLs floating around in scripts, pasted into wikis, shared in email threads, and embedded in code that gets copied into the next quick fix. You can't rotate culture, you can rotate credentials. So if Python triggers Power Automate, it must do it as an authenticated, authorized principal with explicit permissions, and the flow must enforce those assumptions. The caller identity shouldn't be anyone who knows the URL. It should be a workload identity you can disable, scope, and audit. Bidirectionality matters because it decouples business coordination from compute. That's the entire point of the 3-tier model. You want the workflow to remain stable even as the execution logic evolves, and you want execution to scale and change without rewriting the business process layer. Both directions support that decoupling, but only if they share 1 governance standard. Here is that standard, and it's non-negotiable. Every cross-tier call must be authenticated, authorized, and logged. Authenticated means the caller proves who it is, using tokens, not shared secrets stuffed into a flow action. Authorized means the caller can only do the specific thing it needs to do, not contributor on the whole resource group, because it was faster. Logged means the call creates evidence: who called, what was requested, what was returned, how long it took, and why it failed. And yes, the log requirement is part of the interface. If you can't correlate the flow run to the function invocation to the downstream Dataverse operation, you do not have an architecture. You have a distributed guessing game. This is also where people start arguing about tools, functions versus containers, APIM versus direct calls, private endpoints versus public with IP restrictions. Those details matter later. First, you decide the behavioral rules. The hybrid mandate doesn't care whether you like Python or dislike it. It cares whether the execution tier behaves like a governed service. It cares whether the orchestration tier remains readable and survivable. It cares whether Azure enforces the boundaries you claim exist. So pick your direction based on the event source, but enforce the same governance standard either way. And start where every boundary decision starts, whether you admit it or not: identity. Identity boundary, flow authenticated via Entra ID. Identity is where hybrid architectures either become governable or become folklore, because the first thing most people do when they connect Power Automate to some Python is borrow a human. They create a connection with their own account, test it, publish it, and move on. It runs, the business is happy, and now production depends on one person's token refresh behavior, licensing status, MFA prompts, password resets, and eventual offboarding. That isn't automation. That's employee impersonation at scale. In the hybrid mandate, every cross-tier call is a workload call, not a human call. That means the principal has to be explicit, named, owned, auditable, and designed to survive leadership changes, reorgs, and attrition, because those are the only constants in enterprise IT. So start with the hard rule. Stop using some user's credentials for anything that runs without a user present. If a flow needs to call the Python execution tier, typically an Azure function, container endpoint, or a service behind API management, then the flow must authenticate using Entra ID as a workload identity. In practice, that usually means one of two things: a service principal or a managed identity. A service principal is the classic pattern: an app registration in Entra ID with defined permissions, a credential, and a clear lifecycle. It's fine. It's also where entropy enters, because people treat client secrets like passwords and then paste them into places they don't belong. A secret in a flow action, a secret in an environment variable that's shared across environments, a secret in a wiki page because the COE needs it. Then 6 months later, nobody knows where it's used, so nobody rotates it. Now the secret is permanent, and permanent secrets are a design failure. A managed identity is what enterprises should prefer when the execution tier lives in Azure. It removes the secret handling problem entirely. The runtime gets an identity. The identity gets permissions. Tokens are issued automatically. Rotation is no longer your problem. That's not convenience. That's reducing attack surface and operational toil at the same time, which is rare enough that you should take it whenever you can. But whether you use a service principal or managed identity, the critical behavior is the same: token-based calls with least privilege. The execution tier should accept only valid tokens from known callers. It should validate audience, issuer, and claims. It should reject anonymous calls, shared keys, and its internal assumptions. And the identity should be scoped to exactly what it needs. Call this API in this environment with this role. Not contributor because it was faster. Not owner because troubleshooting was annoying. Those shortcuts don't stay temporary. They become the architecture. This is also where conditional access enters the chat and quietly ruins people's day. Non-interactive workloads don't do MFA prompts. They don't pass device compliance checks. They don't open a browser. So the tenant needs conditional access policies that explicitly account for service principals and managed identities. Otherwise, you'll oscillate between two failure modes. Either you block the workload and break production, or you exempt it broadly and create a permanent bypass. The hybrid mandate doesn't accept either. The identity boundary must be designed as a first-class workload pattern. Dedicated principles, explicit assignments, and policies that treat automation as automation, not as a human pretending to be a robot. Now, the ownership model. This is the part everyone avoids because it forces accountability. Who owns the app registration? Who owns the managed identity? Who owns the API permissions? Who owns incident response when the principal starts getting denied? If the answer is the maker, you've already lost, because makers don't own Entra posture. Security and platform teams do. If the answer is the cloud team, but they don't own the flow logic, you've split responsibility without a contract. So, define it. Makers own orchestration artifacts, engineers own execution services, and platform security owns identities and policy. And yes, that sounds bureaucratic. It's not. It's survivability engineering. Because when an employee leaves, a flow authenticated as them becomes an outage with a calendar invite. When a flow authenticates as a workload principal, offboarding is irrelevant. The system keeps running, and the audit trail still points to a non-human identity that can be governed, rotated, and revoked without rewriting the business process. This is why identity is the first boundary. It determines every other boundary. But identity without network containment is still an exposed surface. So next comes the network boundary, where private stops being a vibe and becomes a property. Network boundary, private endpoint for the function. Network is the part everyone hand waves with, it's in Azure, so it's fine. That sentence has funded more incident retrospectives than any attacker ever has. If the Python execution tier sits behind a public URL, you've created a permanent exception. Maybe you lock it down with a function key. Maybe you add IP restrictions. Maybe you stick it behind a WAF later. But the physics don't change. You made your execution tier internet reachable, and now you will spend the rest of its life explaining why that's acceptable. This is the uncomfortable truth. Public endpoints become policy dead. They start as temporary, then they become dependency, then they become sacred. Once flows, scripts, and systems depend on that endpoint, nobody wants to break it to fix it, so it stays public. Forever, with just one allow list, with just one bypass for a partner, with just one exception for a test tool. And then you're back to conditional chaos, except now it's network-shaped. Private endpoint exists to stop the argument. Private endpoint makes reachable a governed property. The service is still the same function app. The code is still the same Python. But the front door moves off the public internet and into your private address space. That means if something wants to call the execution tier, it has to be inside your network boundary, or it has to come through an explicitly governed ingress point. That distinction matters because identity without containment is still an attack surface. Entra proves who is calling, network proves from where. If you only do identity, you're still betting that nobody can reach the endpoint except the callers you intended. That's not an architectural guarantee. That's a hope with certificates. So what does this look like in a hybrid mandate? The Python execution tier runs in Azure Functions. The function gets VNet integration for outbound, then you expose inbound through private endpoint, so the function's runtime is reachable only via private IP with private DNS resolution. Now your API isn't on the internet with rules. It's an internal service with an explicit entry path. And yes, there are multiple patterns depending on how strict you need to be and what else you're integrating with. The details change. The principle doesn't. You don't make your execution tier public just because it's convenient for a flow action. There's an immediate pushback here. But Power Automate is SaaS. How does it call a private endpoint? That question is exactly why network boundaries force architectural clarity. If a SaaS orchestrator has to call into a private execution tier, you need a deliberate bridge, not a leak, not a random public exception. Sometimes that bridge is API management with private backend connectivity acting as a controlled ingress with policy enforcement. Sometimes it's a relay pattern, sometimes it's a queue. The flow writes a message to a governed broker, and the execution tier pulls it from inside the network. The hybrid mandate doesn't require one specific implementation. It requires that the bridge is explicit, auditable, and owned, because the failure mode is predictable. If the flow can't reach the function privately, people will make it public for now. And for now is how permanent exposure happens. Private endpoint also forces you to get serious about outbound paths. A function app can talk to anything by default if you let it. That means the execution tier can quietly become a data exfiltration engine with legitimate credentials. Private networking and controlled egress through native, firewalls, or inspected routes turn outbound traffic into something you can actually reason about. Not perfectly, but architecturally. And when you do that, you change the operating model. You stop treating the execution tier like a hobby project and start treating it like production infrastructure, governed ingress, governed egress, named dependencies, and no surprise internet reachability. The business benefit isn't security theater, it's stability. When an endpoint is private, random internet noise doesn't hit it. Scanners don't find it. Opportunistic probing doesn't become your baseline. You reduce the ambient attack traffic that everyone pretends doesn't matter until it does. So the network boundary is simple. The Python execution tier lives behind private endpoint. If something needs to reach it, it does so through a designed path, not a public exception. And once you accept that, the next boundary becomes obvious. Network controls are pointless if the data path is still unmanaged. So now you define the data boundary. Dataverse stays inside the platform, and you stop pretending direct external access is just integration. Data boundary. Dataverse never directly exposed externally. Dataverse is where organizations accidentally confuse accessible with governed. Because Dataverse feels like a database. It has tables, rows, relationships, and an API surface. So the instinct is obvious. If Python needs data, just let Python talk to Dataverse directly over the API. Get the job done. That instinct is how the data boundary collapses. In the hybrid mandate, Dataverse is the governed system of record that stays behind the platform. It is not an integration playground for every script that wants a shortcut. The reason isn't moral, it's mechanical. The moment you expose Dataverse directly to external execution runtimes, you multiply the number of identities, endpoints, and permission models that can touch your core business data. You're not integrating, you're expanding the blast radius. And blast radius is what audits actually measure, even when they pretend they're asking about policies. So the rule is simple. The execution tier talks to a controlled interface, not to Dataverse endpoints. Power Platform orchestrates access to Dataverse, and Azure governs the interface that crosses tiers. That means the Python tier should not be running an SDK that casually reads whole tables because it can. It should be calling a service contract that gives it only the minimum payload needed to compute. If the execution tier needs 12 fields, it gets 12 fields, not the record, not the table, not a just-in-case dump because it was convenient. This might seem restrictive. It's not. It's what keeps your tenant from turning into an accidental data lake full of copies, caches, and half-deleted exports. Think in terms of the authorization graph. When a flow reads Dataverse, it does so through a governed identity and an environment boundary that your platform team can see. When a random script reads Dataverse, you've shifted access into places you don't inventory well. Developer machines, notebooks, build agents, containers, and service principals that end up overprivileged because it kept failing. That is the erosion path. Complexity creates friction, friction creates privilege escalation, and privilege escalation becomes permanent. The clean pattern is mediated access. Power Automate or a governed API tier reads from Dataverse and sends a narrow payload to Python for execution. Python returns a narrow result, normalized data, validation outcomes, dedupe decisions, inference scores, whatever the use case requires. Then the orchestration tier commits back to Dataverse through its governed pathways. This is not about performance, it's about control, because commit is where damage happens. Reads can leak, writes can corrupt, so the architecture has to make writes boring, predictable, and policy-bound. Dataverse writes should happen through patterns you can audit, throttle, and correlate, not through scripts that mostly follow the rules. The other part of the data boundary is DLP alignment, and this is where most organizations get exposed while thinking they're protected. DLP policies in Power Platform can restrict connector pairings. They can prevent Dataverse data from flowing into consumer connectors. But if you let Python pull data directly from Dataverse, then DLP becomes irrelevant. The data has already crossed the boundary into an uncontrolled runtime. From there, it can go anywhere: files, outbound APIs, third-party libraries, random storage accounts, or temporary folders that somehow last for years. So if you care about DLP, you have to care about where the data exits. The execution tier must receive only what it needs, and it must operate inside the same governance story: identity, network containment, and logged egress. Otherwise, DLP is theater applied after the data already left. And yes, there are legitimate cases where pro developers will say, but the Dataverse SDK for Python exists, or we can use service-to-service authentication, or we can lock it down with least privilege. Those are tools. They are not a boundary. A boundary is an architectural rule that survives staff turnover, project pressure, and the next urgent request. If your boundary depends on every engineer remembering to do least privilege perfectly, you don't have a boundary. You have good intentions. The hybrid mandate treats Dataverse like a protected core. It stays inside the Power Platform trust envelope. Everything outside talks to it through explicit contracts that you can version, validate, and monitor. That reduces the number of paths into your system of record, and it keeps your data movement explainable when the inevitable question arrives: where does this data go? So the data boundary is the line that keeps your system coherent. Dataverse never becomes a public dependency of the execution tier. Once you accept that, the next boundary becomes unavoidable. If Python talks to a controlled interface, then that interface has to be managed as an API, not as an ad hoc endpoint. And that's where the API boundary enters. The function gets wrapped in API management, whether you like it or not. API boundary, function wrapped in API management. Once Dataverse stops being directly reachable, you need an interface that can carry the load of that decision. And this is where most hybrid designs quietly collapse. They treat the Azure function like an API product, but they operate it like a shared script. API management exists to stop that drift. Not because APM is magical, it isn't. It's because enterprises need a place where policy becomes enforceable consistently across every caller. If you let every flow call the function endpoint directly, you get the same outcome you always get in Power Platform. Hundreds of slightly different clients, each with their own expectations, timeouts, payload quirks, and retry behaviors. And then your service isn't a service, it's a compatibility hostage. APM is the contract boundary. It's where the execution tier becomes an actual product. Versioned endpoints, documented schemas, predictable error shapes, and policies that don't depend on every maker remembering the rules. It's also where you centralize throttling and abuse control so the orchestration tier can scale without DDoSing your own backend by accident, because that happens. Power Automate retries are not polite. Parallel branches are not polite. Apply to each with concurrency turned on is definitely not polite. So if you don't have a choke point, your execution tier will get load patterns that feel like an attack, except they're coming from your own tenant with legitimate permissions. APM gives you a place to enforce rate limits, quotas, header requirements, payload size, and response timeouts, not as guidance, as reality. It also gives you a place to enforce authentication consistently. You already decided cross-tier calls must use Entra-based workload identity. APM lets you make that the default behavior. Validate tokens, validate audiences, reject unknown issuers, reject missing scopes, and do it before the request ever reaches your function runtime. That distinction matters because functions are execution. They should spend CPU doing compute, not doing gatekeeping for every caller variation you forgot to constrain. Then there's the part everyone ignores until the platform turns on them. Versioning. Flows live for years. Makers copy them. Departments fork them. Someone saves a template in a team and suddenly you have 50 clones calling your endpoint. If your function API changes shape and you don't have a versioning story, you'll break production in places you can't even find. APIM is where you make versioning boring. V1 does what it always did. V2 exists when you need to evolve. Deprecation becomes a planned lifecycle event, not a surprise outage. And you can instrument which clients still hit V1 so you can actually drive retirement. That's governance, not policy documents. APIM also forces contract discipline, which is the opposite of just pass JSON. The execution tier should reject ambiguous payloads. If a field is required, it's required. If a schema changed, the caller needs to know. If an array is too large, fail fast. If a content type is wrong, reject it. The point is to stop garbage in from becoming mysterious behavior that you debug at 3 a.m. Power Platform teams hate this at first because it feels strict. It's supposed to. Strict contracts are what keep orchestration maintainable. When flows can send anything and the backend tries to guess intent, you're back to probabilistic behavior. You're back to exceptions being architecture. APIM lets you enforce validation and normalization at the boundary so both sides stay honest. And yes, APIM is also the right place for transformation policies when you absolutely need them. Rewrite headers, map fields, standardize error responses, even do lightweight filtering. The rule is simple. APIM enforces interface behavior. Python executes business compute. Don't rebuild your service logic and policies. That's just moving the mess to a different UI. Finally, APIM is how you stop every flow from becoming an API client with custom quirks. Without APIM, makers will do what makers always do. Set weird timeouts, ignore error codes, parse text, and implement retry logic by adding delays. With APIM, you can publish a single standard. This is the endpoint, this is the contract, this is the auth, this is the expected response, this is the error model, and this is the throttling behavior. Now your hybrid mandate looks like a system, not a diagram. And this is the actual payoff. APIM becomes the layer that lets the backend evolve while orchestration stays stable. Engineers can patch dependencies, optimize compute, or refactor internal modules without asking makers to rewrite business process logic. The contract holds, the orchestration tier keeps coordinating, the execution tier keeps executing. But none of this matters if you can't see failures across tiers. Governance doesn't fail loudly, it fails silently. So the next boundary is the one that makes incident response deterministic. Correlated logging across Power Platform, APIM, and the execution tier. Logging boundary, correlated logs across systems. Logging is where hybrid architecture stops being a diagram and starts being debuggable. And most organizations fail here in the most predictable way possible. Every system logs its own truth in its own format with its own identifiers, and then the incident bridge call becomes a group project in interpretation. Power Automate has run history, APIM has request logs, Azure Functions has application insights traces. Dataverse has audit logs and its own activity telemetry. They all tell a story. They just don't tell the same story. So when a flow run fails, you get the comfortable lie. The flow failed at the HTTP action. That's not a root cause. That's a location marker. The real question is whether the request hit APM, whether APM rejected it on policy, whether the function code threw an exception, whether the function timed out, whether the downstream call to Dataverse was denied, and whether retries created duplicates that are now someone else's problem. If you can't answer those questions in minutes, you don't have observability. You have distributed journaling. The logging boundary in the hybrid mandate is explicit. One correlation ID must cross the orchestration tier, the API boundary, the execution tier, and any governed data operations. The same identifier shows up everywhere, every time, no exceptions. Because once you have that, incident response becomes deterministic. You stop guessing, you stop screenshot archaeology, you stop fighting over whose logs are right. You query the correlation ID and you see the end-to-end path of the transaction. So how does this work mechanically without turning into an implementation lecture? Start in Power Automate. The flow generates a correlation ID at the start of the run, not at the HTTP step, not inside Python. At the first moment, the orchestration tier decides work is happening. That correlation ID becomes a variable, and it gets attached to every cross-tier call, request headers, payload fields where appropriate, and any status records you write to Dataverse. Then APIM enforces it. If the correlation ID header isn't present, reject the request. This is the part that feels rude until you remember what you're buying. The ability to operate at scale without ambiguity. APIM can also generate one if you want, but the stronger pattern is to let orchestration originate it so it maps cleanly to a flow run. Next, Azure functions. The function code reads the correlation ID, sets it as the operation ID in its telemetry context, and logs every meaningful step against it: validation outcomes, branch decisions, downstream calls, and exceptions. Not verbose debug noise. Evidence. Then, downstream data operations. If the function writes to Dataverse through a governed interface, that interface must also log with the same correlation ID. If the orchestration tier writes to Dataverse directly, it writes the correlation ID into the record or an associated tracking table, so you can tie business state to technical execution. Now you can answer questions that otherwise turn into week-long postmortems. How long did the request spend in Power Automate before it left the orchestration tier? Did APM throttle it? And if so, how many times? Did the function execute, or did it fail authentication at the edge? Did the function time out, or did it throw a handled validation error? Did retries occur, and were they idempotent or duplicative? How large was the payload, and did it cross the thresholds that trigger platform limits? Did permission denials occur, and which principal got denied? Those are the metrics that matter: latency, failures, retries, payload size, throttle events, and authorization denials. Not because dashboards are fun, but because these signals tell you where architectural erosion is happening. And yes, you should push these logs somewhere central. Azure Monitor and Application Insights are fine. Sentinel becomes relevant once you care about threat detection and not just troubleshooting. The product choice matters less than the behavior. Centralize, correlate, retain, and make it searchable by correlation ID and principal. This is also where you learn the uncomfortable truth about low-code observability. Power Automate will show you what it did. It will not show you what your execution tier did. Your execution tier will show you what it did. It will not show you what Power Automate assumed. Without correlation, those gaps fill with human narratives. With correlation, they fill with data. And once you have correlated logs, the rest of the hybrid mandate becomes enforceable. You can prove boundaries exist. You can prove calls are authenticated. You can prove data didn't move where it shouldn't. You can prove which tier failed and why. That's what governance looks like when it's real. Evidence, not confidence. Now you can finally define the workflow end-to-end as a system, not a collection of parts. Conceptual flow, event, reasoning, orchestration, execution, commit. Now stitch the tiers together into a single conceptual flow, not because architects love diagrams, because your incident response team needs a mental model that survives pressure. The sequence is simple: event, reasoning, orchestration, execution, commit. 5 verbs, 5 places where intent can drift if you don't pin it down. Start with the event. The event is the moment reality changes and the system notices. It can be an email arriving with an attachment, a Teams message, a form submission, a Dataverse row being created or modified, a scheduled trigger that checks for late invoices, expiring contracts, or missing compliance attestations. The event source doesn't matter. What matters is that events are noisy. They contain malformed inputs, duplicates, and human chaos. So the event isn't where you do the work. It's where you decide whether work should happen. That decision is the reasoning layer. Reasoning is not execution. Reasoning is classification and routing. It answers, is this request valid enough to process? And who owns the outcome? Do we need an approval? Which environment does this belong in? What category of work is this? Simple automation, high-risk change, or something that requires escalation? This is where Power Platform earns its keep. A flow can apply cheap logic fast. Subject line filters, sender allow lists, basic field validation, lookup of a business owner in Dataverse, routing to an approval, or branching based on process state. Keep it readable, keep it explainable. When a compliance lead asks why a record went down a particular path, the answer should be visible without reverse engineering Python. Then comes orchestration, which is the part most people confuse with execution. Orchestration is coordination over time. It creates a tracking record. It sets a correlation ID. It moves a process from state A to state B. It informs humans. It waits. It retries intentionally. It escalates when the process sits too long. It records that something happened even if the execution tier is currently unhealthy. This is where you enforce that the workflow is the system of record for the process, not the Sidecar script and not the API logs. If the execution tier dies, the orchestration tier should still know what it asked for, when it asked for it, and what it's waiting on. Now you cross the tier boundary into execution. Execution is where Python runs, but the key is that it runs as a service call, not as a vibe. The orchestration tier sends a bounded payload with a correlation ID and a contract version. The execution tier validates the payload, performs deterministic compute, and returns structured results, success, failure type, output data, and per item errors when it's batch work. This is also where idempotency belongs. The execution tier should treat the correlation ID as a first-class input, so retries don't create duplicates. If you rerun the same request, you should get the same outcome, or a clean, already processed response. Anything else becomes retry storms and data drift. Then you get to commit. Commit is where enterprise data changes, and it has to be boring. Commit means writes back to Dataverse or other systems of record through governed endpoints with strict permissions and logged outcomes. Commit isn't Python writes wherever it wants. Commit is the system records results through known paths. Sometimes the orchestration tier does the commit using native connectors and environment-bound permissions. Sometimes the execution tier commits through an API boundary. Either way, the rule stays intact. Writes happen through interfaces that are authenticated, authorized, and observable. And finally, the orchestration tier closes the loop. It updates status, notifies stakeholders, and stores the execution output in a form the business can actually consume. Not raw logs, not screenshots, data. So that's the sequence. Event decides that something might matter. Reasoning decides what should happen. Orchestration manages the process. Execution does deterministic compute. And commit records the outcome safely. If you can't name which tier owns each verb, you don't have a hybrid model. You have cross-system guesswork. Now make it tangible because abstract models don't survive first contact with spreadsheets and bulk updates. Scenario 1. CSV, Excel processing without flow spaghetti. This is the scenario that shows up in every enterprise, regardless of how digital the strategy deck looks. Spreadsheets. Finance lives in Excel, operations lives in CSV exports. Vendors send reports that are really just semi-structured guesses with a header row. And somehow all of that becomes a business process with deadlines and consequences. Power Automate can process these files. Of course it can. That's not the debate. The debate is what happens after the third small tweak and the fifth edge case and the 10th file format. That's basically the same. This is where flows become spaghetti. A maker builds a flow that triggers when a file lands in SharePoint. It lists rows in a table. It loops. It transforms text. It converts date formats. It tries to handle commas inside quoted fields. It tries to ignore blank rows that aren't blank. It tries to detect the total line someone left at the bottom. Then it tries to build error handling inside scopes because a single bad row shouldn't fail the whole run. Then someone asks for a summary email with the rows that failed. And now you're building an error report generator inside an orchestration engine. This is how you end up with a flow that is both fragile and expensive. So in the hybrid mandate, the split is clean. The flow owns intake, permission checks, status tracking, and notifications. It does the work that's inherently orchestration. A file arrived. This is the owner. This is the process state. This needs approval. Notify these people. Record that we attempted processing. Record that processing succeeded or failed. The flow does not own parsing, normalization, deduplication, validation logic, or report formatting. Not because makers aren't capable. Because that logic needs determinism and testability, and those are not native properties of a flow run history. So the flow receives the file, stores it in a governed location, and calls the execution tier. The execution tier, Python as a service, does what Python is good at. It reads the CSV or Excel with a real library built for it. It normalizes columns into a defined schema. It handles date parsing with strict rules. It detects duplicates using keys you can explain and unit test. It validates every row against an explicit rule set and returns results as structured data, accepted rows, rejected rows, and why each row failed. And here's the part most organizations miss. Errors come back as data, not as screenshots. In the low-code-only approach, a failure becomes an exception with a blob of context that's hard to aggregate. In the hybrid approach, the Python service returns a result contract that looks boring on purpose, counts, row-level status, a list of validation messages with line numbers or record identifiers, and a correlation ID. Now the flow can do what it's actually good at. It can route those errors. If there are rejections, it can notify the submitter with a formatted summary and a link to the rejected rows stored in a controlled table or file. If the batch is clean, it can progress the process state and trigger downstream work. If the batch fails validation beyond a threshold, it can escalate to a human review step. And all of that remains readable in the flow because the heavy logic is not embedded in a maze of expressions. This is also where you stop leaking data through convenience. If the execution tier is a governed service behind APIM authenticated via Entra, contained by network boundaries and emitting correlated logs, then processing a spreadsheet no longer means dump business data into random files and hope it's fine. It means the file enters a controlled pipeline, intake, execution, and commit with evidence at every step. And the output contract matters more than the implementation. Because once you have a stable contract, you can evolve the Python logic without rewriting the business process. You can add a new column mapping. You can update a validation rule. You can patch a dependency. You can optimize performance. The flow doesn't change. The process owners don't have to relearn the automation. The orchestration tier stays stable while execution improves. And that's the actual maturity move, not we used Python. We separated orchestration from execution and we made the boundary explicit. So the spreadsheet scenario stops being a maker rite of passage and becomes a governed service pattern, flow coordinates, Python computes, Azure enforces. And once you've done it for CSV and Excel, the next failure mode becomes obvious. It's not formatting, it's scale. Bulk updates, throttles, partial success, and the classic enterprise question. Can we do 10,000 of these by tomorrow without corrupting our data? Scenario 2. Bulk Dataverse updates with deterministic validation. Bulk updates are where Power Automate's "it worked in testing" story usually ends. Not because flows can't update Dataverse. They can. The failure happens when you move from dozens of records to thousands, and the platform stops behaving like a friendly assistant and starts behaving like a rate-limited distributed system. Because that's what it is. The usual pattern is painfully consistent. Someone builds a flow that queries Dataverse for a set of rows, then runs an apply to each, then does an update a row action, maybe with concurrency turned on to speed it up, and then adds a couple scopes with run after conditions to catch failures. It ships, it runs. It even succeeds a few times. Then scale shows up, throttling shows up, intermittent connector errors show up, runs time out, retries kick in. Some updates succeed, some fail, and the flow has no coherent concept of rollback. Now you have partial success with no deterministic replay strategy, which is another way of saying you have data drift with a progress bar. And the real damage isn't the failures, it's the ambiguity. When someone asks which records were updated, the answer turns into, well, mostly. That's not acceptable in a system of record. So the hybrid mandate treats bulk updates as an execution tier problem, not an orchestration tier hobby. Here's what stays in the flow. Intake of the request, approval if it's a high-impact change, creation of a tracking record in Dataverse, and communication to stakeholders. The flow also decides the boundary conditions. Which table, which segment, which job type, which correlation ID, and what done means. The flow owns the business meaning. Then it calls Python as a service, and Python does two things that flows are structurally bad at: deterministic validation and deterministic batching. Start with validation. Before Python writes anything, it validates the entire candidate set, not one row at a time, mid-loop, with half the records already committed. The execution tier pulls the necessary fields through a controlled interface, applies strict rules, and produces a validation report. Counts, categories of failure, and per record reasons. This is where you stop confusing update logic with data quality. If you're about to update 10,000 records, you don't want to discover on record 7,732 that the data violates a rule, and now you're in the middle of a half-applied change. Validation first is what makes the operation reversible. You can reject the whole job before it mutates reality. Then, batching. Python controls how writes happen. Chunk sizes, back-off retry strategy, and idempotency keys. It writes in batches you can reason about, and it records outcomes per batch and per record. If a batch fails, you know exactly which records were in it. If a retry happens, it doesn't create duplicate updates because the execution tier treats the correlation ID plus record identity as a first-class idempotency input. That's the deterministic part. The same job produces the same outcomes, even under retries, even under throttling, even under transient failures. And now the critical governance rule from earlier stays intact. No direct external Dataverse exposure. Python doesn't get to talk to Dataverse however it wants, just because it's back-end code. You still enforce the mediated pattern. The execution tier writes through governed endpoints. That might be an API behind APIM that performs the writes with a controlled identity and logs every operation. Or it might be the orchestration tier doing the final commit based on the execution tier's output. Either way, you don't let bulk mutation become a free-for-all just because the code is in Python, because bulk mutation is where least privilege gets murdered first. Engineers get tired of permission errors, so they grant broad roles. Makers get tired of failures, so they ask for exceptions. Exceptions become permanent, entropy wins. So you design the right path to be narrow by default. Specific tables, specific actions, specific scopes, and audited principles. Now look at what becomes possible once the execution tier owns the bulk job. You can return per record status as actual data, updated, skipped, rejected, already compliant, conflict detected, and why. You can store that in a Dataverse table as the job ledger. You can produce a human-readable summary for the business, but you still keep machine-readable truth for incident response. And you can do the one thing enterprises always pretend they don't need until they do. Prove what happened. Not the flow ran successfully. What records changed, what values changed, who authorized it, what job produced it, and what correlation ID ties every step together across flow, APM, and function logs. That's how bulk operations stop being terrifying. The flow becomes the request and approval layer. Python becomes the deterministic execution engine. Azure becomes the enforcement layer that makes identity, network, and logging non-negotiable. And once you've solved bulk updates, the next question shows up immediately, usually from the same teams that caused the bulk update problem in the first place. They want to add just a little AI to the process. That's where things go from expensive to unpredictable if you don't keep the same tier boundaries. Scenario 3. ML inference as a governed service, not a maker experiment. AI is where the hybrid mandate gets tested because AI tempts people into skipping architecture. A maker sees an action that can call an LLM, drops it into a flow, and suddenly the workflow thinks. It demos well, it even ships. Then finance asks why the monthly bill doubled. Legal asks how decisions get explained. Security asks where prompts and outputs went. And the business asks the only question that matters: why did the same input produce a different result this week? This is the risk. Embedding inference directly in flows turns cost, behavior, and governance into a probabilistic mess. The orchestration tier was never designed to be your model runtime, your prompt management system, and your safety layer. When you force it to be, you get conditional chaos with a token budget. So the rule stays consistent with everything else. Inference belongs in the execution tier, not in the orchestration tier. The why is simple. ML inference is compute with consequences. It needs deterministic wrappers, even when the model itself is stochastic. It needs versioning, it needs guardrails, it needs auditable inputs and outputs, and it needs a place where engineers can fix it without opening 50 flows and praying they all use the same prompt. In the hybrid pattern, Power Automate still does what it's good at. It routes the business process. It decides when inference should happen, who is allowed to request it, what record it's tied to, and what happens next. It does not own the prompt, the retry logic, or the passing of untrusted model output. That's execution. So the flow calls a Python service behind APIM, authenticated via Entra with network containment and correlated logging. Same as the CSV and bulk update scenarios. The only difference is the workload. Instead of parsing files or batching updates, Python is invoking a model, preparing features, and returning stable outputs. Here's what Python does that flows shouldn't. First, input shaping. Most AI in flows failures start with garbage inputs: unbounded text, missing context, sensitive fields accidentally included, or random formatting that makes the model behave differently. The Python tier normalizes and constrains input. It can trim, redact, classify, and reject payloads before they ever hit a model endpoint. That's not optional, that's your safety boundary. Second, prompt and configuration versioning. Inference isn't just call the model, it's a specific prompt template with a specific system message, with specific tool settings, with specific temperature and max tokens, and often with specific grounding data. If that configuration lives inside a flow action, you've turned prompt engineering into a distributed configuration drift problem. Every copied flow becomes its own model behavior fork. Nobody can answer which version is running where. Entropy wins again. So the execution tier owns prompt versions like code artifacts. Version identifiers become part of the response contract. When the business asks why behavior changed, you don't argue about vibes. You point to a version and a change record. Third, guardrails and deterministic post-processing. Model outputs are not structured until you force them to be. Flows tend to treat model text like truth and then parse it with expressions that break the moment the model gets creative. The Python tier can enforce strict output schemas, validate fields, reject malformed results, and apply deterministic rules that the business can audit. The model can suggest, the service decides what counts. That's the uncomfortable truth executives need to hear. AI doesn't replace policy. AI needs policy codified, because otherwise it becomes a liability generator. So what comes back to the flow? Not raw text, not here's the model's opinion. The execution tier returns stable, bounded outputs, a classification label, a confidence score if you choose to expose it, a set of extracted fields, a decision recommendation with a reason code, and any warnings. If the model can't comply with the schema, the service returns a failure type the orchestration tier can route, retry, human review, or reject. Now you get the enterprise behaviors you actually want. Cost becomes governable, because APM can throttle and you can measure token usage at the service boundary instead of hiding it in flow runs. Behavior becomes governable because prompts and parsing live in one place with version control. Auditability becomes possible because you can log inputs, outputs, and config versions with correlation IDs tied back to the flow run and the Dataverse record. And you can finally separate AI experimentation from AI in production without pretending makers won't experiment. They will, they should. But experiments belong in a green zone with controls, not in production flows that approve payments, update customer records, or trigger compliance actions. The hybrid mandate doesn't ban AI in Power Platform. It contains it. Flow stays orchestration. Python does execution. Azure enforces governance. And inference becomes a service with contracts, boundaries, and evidence, rather than a maker experiment that slowly turns into policy drift with an invoice. Scaling reality, limits, throttles, and the conditional chaos tax. Scale is where your architecture stops being an opinion and starts being a physics problem. Power Automate has run limits. Connectors have throttles. Dataverse has service protection limits. APIM has quotas. Functions have execution timeouts. None of these are negotiable, and none of them care that a VP needs the workflow by Friday. So when an automation succeeds and gets adopted, it immediately becomes a scaling test you didn't design for. Volume rises, concurrency rises, payload sizes creep up because someone adds just one more field. And then the platform does what distributed systems always do. It applies back pressure, starts rejecting calls, and forces you to learn the difference between a deterministic system and a probabilistic one. Here's what most people miss. Throttling doesn't just slow you down, it changes behavior. A flow that hits connector limits doesn't fail cleanly. It retries, it delays, it sometimes partially completes depending on where it hit the limit. And because many flows don't implement idempotency, retries don't replay safely. They duplicate work, they create conflicting updates, they send duplicate emails, they create double approvals. They write the same record twice with two different values depending on what data changed between attempts. That's the conditional chaos tax. Not because Power Platform is unreliable, because your design assumed linear execution in a world that enforces distributed constraints. So treat scaling as a first-class boundary decision, not a performance afterthought. The orchestration tier needs to stay lean. That is not a preference. It's the only way the system remains survivable when adoption doubles. Every extra action in a flow is an additional failure surface. Another timeout, another connector dependency, another retry path, another place where errors can be swallowed and re-emitted as unknown. And yes, people will argue that low code makes it easy to add steps. That's exactly the problem. It's easy to add steps that become permanent. It's easy to add exceptions that become policy. It's easy to keep shipping until you have a flow that is effectively a data pipeline with a UI, and those fail in slow, expensive, non-deterministic ways. So the hybrid mandate applies the same pressure as before. Move compute out, keep coordination in. If you're doing bulk operations, don't loop through 10,000 records in Power Automate because you can. You will hit limits, and the workaround engineering will turn into the real logic. Put the bulk work in Python behind APIM, where you can control batching, apply backoff, and implement idempotency properly. If you're doing heavy transforms, don't parse and normalize in a flow because it's just strings. That turns into nested loops, fragile expressions, and a debugging model that depends on run history archaeology. Do it in the execution tier where you can test it, version it, and run it deterministically. And when you do keep orchestration in the flow, you still need to respect the platform's shape. Retries should be intentional, not accidental. If a call fails, you should know whether you're retrying because it was transient or because you hit a quota that won't clear for an hour. That means your execution tier needs failure types that the orchestration tier can route. Throttled, unauthorized, validation error, downstream, unavailable, timeout. If everything comes back as 500, the flow can't behave intelligently. It will just try again until it makes the situation worse. This is where APIM earns its keep again. You throttle at the edge. You don't let 1,000 parallel flows stampede the backend because someone turned on concurrency. You apply quotas per client identity. You enforce payload limits so you don't get surprised 20 megabyte JSON bodies because someone decided to send the entire spreadsheet to be safe. You reject early, consistently, and with a reason code the orchestration tier can understand. And when you need real scale, you queue. Queues aren't trendy. They're how you turn bursty, user-driven orchestration into steady, governable execution. The flow submits a job. The execution tier pulls and processes at a controlled rate. The flow tracks state and notifies humans. That's orchestration behaving like orchestration instead of pretending to be a compute engine. Now the cost part, because cost is where executives suddenly develop strong opinions about architecture. Power Automate costs scale with runs and premium connectors. Execution tier costs scale with compute and throughput. If you keep pushing compute into flows, you pay for orchestration to do execution poorly. If you push compute into Python services, you pay for execution to do execution well. The hybrid mandate is the only model that lets you choose deliberately which cost curve you want. Scaling doesn't reward optimism, it rewards boundaries. And if you don't enforce those boundaries early, you'll enforce them later, under incident pressure, with angry stakeholders and unclear ownership. That's the most expensive way to learn platform limits. So treat limits and throttles as architectural inputs. Design for back pressure, enforce idempotency, throttle at APIM, queue when volume isn't polite. Otherwise, success becomes a tax you pay in conditional C. ALM Discipline, versioned contracts, not versioned screenshots. Once the hybrid pattern works, the enterprise does what it always does. It promotes the prototype to production by continuing to rely on it. Not through a formal release, through repetition. And that's where ALM either shows up as architecture or disappears as ceremony. Power Platform teams often treat lifecycle management as export the flow and import the flow. That's not lifecycle management. That's file movement. It preserves an artifact, but it doesn't preserve intent. It doesn't preserve dependency versions. It doesn't preserve contracts. And it absolutely doesn't preserve the one thing that matters when systems drift, a traceable change story. In hybrid automation, ALM has to be centered on contracts, not canvas, because the boundary between orchestration and execution is not a diagram. It's an agreement. What inputs are allowed, what outputs are guaranteed, what failures mean, and what gets logged. If that agreement changes silently, you don't get a neat failure. You get a slow governance leak. Makers implement workarounds, engineers add temporary compatibility, and within a quarter you've rebuilt the same entropy generator you were trying to escape. So the first rule is blunt, version the API contract like it's a product, because it is. If the Python execution tier exposes endpoints behind APIM, those endpoints need explicit versions, not we'll keep it compatible, not it's just internal. Internal APIs break more businesses than external ones because nobody budgets for internal change management. So you publish V1, you add V2 when behavior changes, you deprecate with a timeline, and you use APM analytics to see which flows still call V1 because otherwise your deprecation plan is a fantasy. The second rule, treat Python dependencies as production supply chain, not as a maker convenience. A requirements.txt that changes because someone ran pip install locally is not an enterprise artifact. The execution tier needs pinned dependencies, repeatable builds, and a controlled promotion path. Otherwise, you will eventually redeploy a function and discover that a transitive dependency updated, behavior changed, and the workflow now produces different outputs for the same input. That's not Python being risky. That's you refusing to manage the execution tier as software. And yes, the same applies to prompts and model configurations if you're doing inference. Configuration is code. If it can change behavior, it must be versioned, reviewed, and released with traceability. Now the Power Platform side. Flows, apps, and solutions also need discipline, but not the fake kind. Versioned screenshots are what teams produce when they don't have deployment artifacts. Here's the run history. Here's the screenshot of the trigger. Here's the expression that worked. That's documentation of accidents, not documentation of design. Real ALM means the flow lives in a solution, uses environment variables, references connections that are created intentionally, and gets promoted through dev, test, and prod like any other artifact. Environment separation is not negotiable in the hybrid mandate. If dev and prod share the same API, the same identities, and the same Dataverse tables, you don't have environments. You have one environment with extra steps. Separation is what makes change safe. Dev calls dev APIM, test calls test APIM, prod calls prod APIM. And the identities are separate because permissions drift differently in each place, and you need the ability to revoke, rotate, and audit without breaking everything at once. Promotion should be gated on traceability, which flow version, which API version, which Python build, which dependency set, which APIM policy set. If you can't answer that on demand, you are not operating a system. You are operating a coincidence. And here's the part that makes people uncomfortable. Ownership has to follow the artifacts. Makers can own orchestration logic, but they cannot be the release managers for execution code. Engineers can own execution services, but they cannot be the only people who understand when a business process changes. Platform teams can own identities and policies, but they cannot be the catch-all for every "it stopped working" complaint. So you need a release contract across teams, makers change flows, engineers change services, platform governs the boundaries, and everyone agrees on what constitutes a breaking change. Because the hybrid mandate is not low-code plus Python. It's a system where drift is expected and managed. ALM is the drift management layer. Without it, your three-tier model collapses back into improvisation. With it, you get the only real enterprise outcome: stable orchestration, deterministic execution, and governance that survives the next reorg. Operating model, COE as entropy management, not a maker police. The hybrid mandate dies in most organizations for a boring reason. Nobody owns the space between maker velocity and enterprise responsibility. So the platform drifts. Not because people are reckless, because the operating model doesn't exist, and systems will always root around missing structure. That's what the Center of Excellence is for, not as a governance theater committee, not as the Department of Note, as entropy management. Because the work isn't stopping makers from building things. That's impossible. The work is preventing the accumulation of invisible exceptions, one-off connectors, ad hoc service accounts, copy-pasted flows, unversioned endpoints, and temporary bypasses that become permanent dependencies. A COE that behaves like maker police creates a predictable failure mode. Makers go quiet, they build anyway, they stop asking questions, solutions move into the dark. And the first time leadership hears about it is during an audit or after an incident, when the response is always the same. How did we not know this existed? So the COE has to be positioned differently. The COE is the team that curates the enterprise patterns that make hybrid safe. Reference architectures, approved integration paths, and the boundary rules that keep orchestration low-code, execution deterministic, and governance enforceable in Azure. The COE doesn't build every solution. It builds the rails that make solutions survivable. That means the COE owns 4 concrete things. First, portfolio visibility. Not a vanity inventory. An actual portfolio with classification. Personal productivity, team workflow, departmental system, enterprise workflow, regulated workflow. Those categories determine which guardrails apply. If everything gets treated like production, delivery freezes. If nothing gets treated like production, entropy wins. Classification is the compromise that scales. Second, patterns and reusable assets. The COE should publish the standard integration contracts, how a flow calls an API, where correlation IDs come from, what APIM policies are non-negotiable, what an error response looks like, what idempotent means in this tenant. Makers don't need a 90-page document. They need a template and a reference implementation that works the first time. Third, the escalation path. Fusion teams are not a slogan. They're an operating model. Citizen makers own orchestration logic and business process. Engineers own the execution tier, Python services, packaging, dependency pinning, performance, and reliability. Platform teams own the governance tier. Entra identities, network boundaries, secrets, logging, and policy enforcement. The COE coordinates those handoffs so work doesn't stall in politics. Fourth, enforcement mechanisms that don't rely on willpower. DLP policies, environment strategy, managed environments, connector governance, APM policy baselines, and identity standards. The COE should define what's allowed, but also make the allowed path the easiest path. If the secure path is harder than the insecure path, you've built a lesson in architectural erosion. Now the part everyone avoids, intake. You need a clear rule for when a flow qualifies for the execution tier. Not because makers can't do it, because the organization can't afford every complex automation to become a bespoke debugging exercise. So the intake criteria should be mechanical. Data transforms beyond simple mapping. Bulk operations above a threshold, long-running jobs, ML inference, cross-environment integration, and anything that touches regulated data with non-trivial logic. When those triggers appear, the COE routes the work into the hybrid pattern. Orchestrate in Power Platform, execute in Python, govern in Azure, and the COE has to defend that boundary in both directions. It needs to stop makers from smuggling execution into flows through scope spaghetti and connector abuse. But it also needs to stop engineers from bypassing orchestration and building shadow services that mutate Dataverse without process visibility. Both are entropy generators, both feel justified in the moment, both become permanent. This is why the COE's job is not approval, it's alignment. Alignment means every hybrid solution has an accountable orchestration owner, an accountable execution owner, and an accountable governance owner. If any of those are missing, the solution is already abandoned. It just hasn't failed yet. And finally, the COE needs to measure drift. Not with vanity metrics like number of apps, with indicators that predict incidents, number of public endpoints, number of flows using personal connections, number of APIs without versioning, number of workloads without correlated logging, and number of solutions living only in the default environment. Those are the cracks where chaos enters. A mature COE doesn't block progress. It makes progress repeatable. And that's the entire point of the hybrid mandate. Agility, but with discipline enforced by design, not by optimism. Executive risk framing, what you're actually buying with the hybrid mandate. Executives don't approve architecture diagrams. They approve risk trades. And the reason the hybrid mandate matters is that it converts a set of vague emotional arguments into measurable enforceable properties. Most leadership teams think they're buying speed when they fund Power Platform. They're not. They're buying the ability to push decision-making closer to the business without collapsing governance. That distinction matters because if the only lever you pull is velocity, the organization will absolutely achieve velocity. It will just be velocity towards sprawl, inconsistent controls, and operational ambiguity. The platform doesn't stop that, it enables it. So here's what you're actually buying with the hybrid mandate. First, lower incident cost through determinism. Incidents are expensive for one reason. Nobody can agree on what happened. The bridge call burns time reconstructing reality across flow runs, connector behavior, and back-end logs that don't line up. The hybrid mandate forces a deterministic execution tier with correlated logging and enforced contracts. That means failures stop being interpretive. They become traceable. Your mean time to innocence drops, which is the only metric leadership should care about during an outage. And your mean time to resolution follows. Second, reduced security exposure through fewer paths to sensitive data. Security teams don't lose sleep over a flow. They lose sleep over uncontrolled identity sprawl and unmanaged egress. When Dataverse becomes directly reachable from arbitrary runtimes, you increase the number of principals, endpoints, and data paths that can leak. That is the blast radius problem. The hybrid mandate shrinks the blast radius by forcing data access through governed boundaries. Entra workload identity, network containment, and policy enforcement at the API edge. You don't eliminate risk, you stop multiplying it. Third, reduced compliance pain through evidence, not assertions. Compliance audits are not asking whether you have policies. They're asking whether policies survive pressure. The hybrid mandate gives you artifacts auditors can understand. Versioned APIs, consistent authentication, bounded payloads, and end-to-end traces tied to a correlation ID. That turns "we think it's controlled" into "here is the record of the decision, the execution, and the commit." Audit conversations get shorter when you can show proof without assembling a narrative. Fourth, reduced vendor lock-in risk by separating orchestration from execution. This is where people get confused. The hybrid mandate is not anti-Power Platform, it's pro-boundary. When you bury your business logic inside flows, you hardwire your enterprise behavior to a tool that was designed for orchestration, not compute. Over time, every workaround becomes a dependency and migration becomes a rewrite. When you externalize deterministic logic into Python services behind stable contracts, you create portability, not because you plan to leave, because you want the option to evolve without ransom. Orchestration can change platforms later. Execution services can be reused. Governance controls remain enforceable. Fifth, better talent alignment and lower organizational friction. Citizen makers should not be carrying the responsibility for runtime patching, dependency management, and API design. Engineers should not be writing approval workflows and chasing inbox rules. The hybrid mandate makes ownership legible. Makers own process orchestration, engineers own execution services, and the platform team owns the governance tier. That reduces the constant debate over who broke it, because the boundaries define accountability before production defines it for you. Now, the uncomfortable executive reality: you are not funding a feature. You are funding an operating model. If leadership mandates low code only, they are choosing a probabilistic security model, because policy exceptions will accumulate until the system behaves differently in each corner of the tenant. If leadership mandates pro code only, they are choosing a delivery bottleneck, because the backlog will outgrow the team and shadow IT will happen anyway. The hybrid mandate is the only position that survives entropy: low code where orchestration is the value, Python where determinism is required, and Azure where governance must be enforced by design. And that's the executive purchase: fewer ambiguous outages, fewer uncontrolled data paths, fewer audit surprises, and a platform that scales without turning into conditional chaos. Closing executive positioning: a maturity model, not a rebellion. The executive positioning has to be explicit, because otherwise the organization will hear what it wants to hear. Some will hear power platform is unsafe. Others will hear engineering wants to take control back. And makers will hear it is about to slow everything down again. All of those interpretations are wrong. The hybrid mandate is not anti-power platform. Power platform is the orchestration tier. That's not a consolation prize. That's the part of the system that touches humans, process, approvals, and business state. It's where intent gets expressed. It's where work becomes accountable. It's where you can see why a decision happened without decompiling a service. So the mandate doesn't reduce power platform. It rescues it from being forced to do execution work it was never built to do. It's also not pro-developer elitism. This isn't about real developers versus citizen developers. That's a childish framing, and it's usually deployed by people who benefit from keeping the boundary blurry. The enterprise needs both skill sets, because the enterprise has both kinds of work: human process and deterministic compute. The mandate simply assigns those responsibilities to the tiers that can carry them without collapsing. Orchestration stays in low code, where it's observable and editable by the business. Execution moves to Python, where it's testable and repeatable. And governance sits in Azure, where identity, network, policy, and logging can be enforced by design. And it is not a workaround for bad design. A workaround is what happens when someone cannot get the platform to do what it should, so they route around controls, file watches, local scripts, service accounts, random endpoints, and just let it through firewall rules. The hybrid mandate does the opposite. It builds the supported, auditable path on purpose, so people stop inventing shadow paths. That distinction matters, because enterprises always end up hybrid. The only question is whether they do it intentionally or whether they do it accidentally in the dark. Now, what is it? It is a maturity model for enterprises that want both agility and engineering discipline. At low maturity, everything lives in the orchestration tier. Flows become pipelines, connectors become integration strategy, and run history becomes the primary debugging tool. It works until it doesn't. Then every exception becomes permanent, and you've converted low-code speed into long-term governance debt. At the next maturity level, the organization introduces the execution tier intentionally. Python becomes a service, not a sidecar. Compute moves out of flows. Contracts become explicit. Idempotency exists. Versioning exists. Payloads are bounded. Makers stop writing brittle parsing logic and start consuming stable outputs. At the mature level, the governance tier hardens the boundaries, so the model survives pressure. Entra workload identity, private endpoints, Dataverse behind the platform, APM enforcing policy and contracts, and correlated logging, so incidents are evidence-based. That's not bureaucracy. That's how systems stay stable while adoption scales. So the hybrid mandate is an enterprise contract, not a diagram. Power Platform is the orchestration tier. Python is the execution tier. Azure is the governance tier, and the point is not to make things harder. The point is to make success survivable. This is also the executive instruction, stated plainly. Mandate boundaries, fund the governance tier, and measure drift. Because drift is what kills you, not the first deployment. Drift, the slow accumulation of exceptions, personal connections, public endpoints, unversioned APIs, and temporary bypasses that quietly become the real architecture. If leadership wants a platform that scales without becoming conditional chaos, then leadership has to stop rewarding outcomes that ignore boundaries. Don't reward we shipped it if it shipped through a backdoor identity. Don't reward we automated it if it exposed Dataverse directly. Don't reward we added AI if nobody can explain the prompt the version, the cost, or the audit story. Reward the pattern, reward the contract, reward the evidence. That's what maturity looks like. The organization can move fast and still prove it stayed in control. The only takeaway that matters is this. Keep orchestration in Power Platform, put deterministic compute in Python, and enforce the boundaries in Azure, or the system degrades into conditional chaos. If you want, I can do a follow-up episode that maps this to a concrete reference architecture, Entra workload identity, APIM policies, private endpoints, correlation IDs, and the minimum viable contracts that stop drift. Subscribe for that and send me the hybrid pattern that's failing in your tenant right now, what boundary collapsed, and what exception became normal.